Imagine looking up at the sky and seeing thousands of delivery drones seamlessly moving packages from warehouses right to our doorsteps. It's like a scene straight out of a sci-fi movie, right? But here's the massive real-world dilemma we're actually facing today. How do you safely manage thousands of delivery drones in the sky when, right now, one human operator can really only safely monitor 5 of them at a time? Welcome to today's Explainer. Today, we're breaking down the exact mechanisms required to maximize drone delivery efficiency. We're relying entirely on the latest research and data from Japan's rapidly advancing drone logistics sector, and we are going to visualize exactly what it takes to unlock the sky.
Okay, let's dive right into our roadmap. We'll start with the current state of drone logistics, then hit the major roadblock known as the profitability wall. After that, we'll explore our core focus, the transition to automated systems and the delicate division of roles between humans and machines. Finally, we'll wrap up with the physical sky infrastructure needed to make all of this a reality. Let's get started.
Section 1. The current state of drone logistics.
Now, as Tokyo University's special professor Shinji Suzuki often points out, while you might rarely see a drone flying in the middle of a massive city right now, they're actually already becoming a real part of regional ecosystems. But notice the magic number we're dealing with right now, 5. Backed by NEDO, which is Japan's new energy and industrial technology development organization, telecommunications giant KDDI and Japan Airlines have achieved a really major milestone. They've successfully developed the technology for a single remote operator to manage exactly 5 drones at the exact same time. Now, 5 might not sound like a massive fleet, but wait until you hear the sheer scale of how they're doing it.
Get this, we are talking about one single operator sitting in a control room in Tokyo, managing concurrent drone flights in Hokkaido way up in the far north, Saitama and Chiba in the central region, all the way down to Kagoshima in the south. It is an absolutely incredible geographic scale run entirely from just one room.
So how does this current operational flow actually work? Well, the system is designed to handle irregularities, things like a near miss with another object or a sudden low battery warning. Step 1, the system detects the issue. Step 2, it sends a screen and voice notification to that operator back in Tokyo. Step 3, the system suggests a workaround, but the operator must manually review the situation and execute the response with system support. You can probably see the bottleneck here, right? It relies so heavily on human visual confirmation. The operator is constantly watching camera feeds and manually checking aircraft statuses.
Which brings us to Section 2, the profitability wall.
If a human operator has to physically watch video feeds and manually authorize every single slight deviation or battery warning, there's just a hard biological limit to how many drones they can safely manage. Just imagine the pure stress of a single person trying to watch 20 frantic live video feeds at once. It's basically a recipe for human error. NEDO has totally recognized this cognitive bottleneck and set a strict immediate near-future goal. By the end of fiscal year 2026, they aim to develop a system where one single operator can manage 10 drones. They're essentially trying to double the current human capacity. But is 10 enough to make drone delivery a booming, profitable business?
Well, here's the crucial reality check from NEDO project manager Noriyuki Hirayama. 10 is really just a stepping stone. He points out that the actual baseline for profitability, the line where this technology becomes a truly viable large-scale business, is 20 drones per person. Managing 20 drones simultaneously is the absolute minimum target we need to hit to overcome the profitability wall.
And this leads us to Section 3, and really our main focus for today's Explainer, the transition to automation.
Reaching that profitable line of 20 drones is quite literally physically impossible if humans are just staring at camera feeds all day. To scale up and maximize delivery efficiency, we require a massive technological leap away from human-centric monitoring. But obviously, you can't just flip a switch to automation without ensuring absolutely perfect safety. As Yusako Hatano at Japan Airlines reminds us, safety measures are a steady activity of raising risks and resolving them one by one. The NEDO project is specifically leveraging JAL's deep historical aviation expertise to systematically map out every possible risk scenario, manual and checklist, to ensure this automated future is rock solid.
So let's define exactly what this transition actually looks like. The autonomous transition is the shift from active, human-centric flight monitoring over to automated systems. As the number of drones increases, the system must semi-automate the detection of and response to irregularities. Basically, it means moving away from a human actively watching a screen to a system that functions passively, catching errors and solving them without constant human visual supervision.
We technically have to eliminate the need for constant visual monitoring if we want to safely scale up operations.
Moving on to Section 4, Human-Machine Role Division.
When we talk about maximizing delivery efficiency through automation, we are definitely not entering some binary humans versus AI or human control versus total autonomy scenario. The reality of a scalable drone logistics network is much more symbiotic than that. But first, let's establish the absolute necessity of the machine. Kenzo Nonami, the robotics division director at FRI, states this perfectly. A system managing thousands or tens of thousands of drones cannot be monitored by humans. Complete autonomy is the premise. At massive scales, the sheer volume of data and flight paths requires an autonomous foundation, but that doesn't mean humans just disappear entirely. This brilliantly illustrates the exact division of roles required for the future. On one side, we have the machine's domain, handling the semi-automated detection of irregularities and effortlessly managing thousands of standard point A to point B flights. On the other side, the human's domain, stepping in for complex situation comprehension and final response approval. More importantly, human flexibility is strictly required because operational scales fluctuate based on dynamic factors. Think sudden weather changes or shifting economic priorities where certain drone deliveries might need to be prioritized over others on the fly. The system must be autonomously managed, absolutely, but with a designated high-level space for human intervention.
Finally, Section 5, Sky Infrastructure and the Future.
We've spent a lot of this explainer looking at the software, the control rooms, and the operators. But to truly support thousands of automated drones, we have to shift our focus to the physical reality on the ground. Journalist Takayuki Kodera makes a brilliant analogy that highlights why scaling drone logistics is fundamentally different, and honestly, much harder than self-driving cars. Think about it. If a self-driving car encounters an emergency on a city street, it can simply stop on the side of the road and wait for an engineer. But a drone? A drone cannot just hit the brakes and stop in midair during an emergency. It has to go somewhere safe, immediately. This physical limitation means we need a massive proactive physical ecosystem, specifically the proactive construction of drone ports everywhere. Kodera suggests that local neighborhood parcel delivery hubs are incredibly promising candidates to be transformed into emergency drone evacuation shelters. Furthermore, the whole development strategy shouldn't just be about limping from 10 to 20 drones. Experts argue we need to design the overarching system assuming thousands of drones right now, and then prove that system's safety by scaling up operations from 10 to 20 using real-world data. If 20 drones per person brings profitability, we need to start building these physical shelters on the ground today. So, we've explored the massive shift from human-centric observation to automated systems, and the precise division of labor required to unlock profitability and efficiency in the sky. It is a truly stunning technological leap. But it brings the reality of this technology right to our front doors. As local delivery hubs prepare to transform into physical drone evacuation ports, I want to leave you with this question to think about. Is your neighborhood ready for this sky's new ecosystem? Thank you so much for joining me for this explainer, and keep your eyes on the skies.